Uh, Welcome back to the lecture. So in this lecture we are going to cover a few things before we can start our database programming in the C# and how we can handle databases. We have a LINQ, that's a language interpreted query, and then we will talk about the link to the objects and link to the XML. So what does that mean? It's kind of a C# query capability which has been integrated in this language. So it's a structured type safe queries over the local objects of collections or the remote data sources, and we are going to use the same kind of the LINQ when we are trying to read the data from our database as well. So that's why I'm making this particular specific base before we can jump into the database queries that we are going to use using the same syntax. So query and any collection implemented in enumerable, it's more like you can query an array, you can ask a specific question to a list or the array list. So these are collections which are present that we have studied earlier in previous lectures. So we have the queries, we have the lists, we have the array list, we have the the collections. So we can query those collections to give us some answers. We can also query the SQL database. We can also query to some web service like API referencing, and then we also have the XML. XML is a well-structured document, and then we can query that particular specific XML document that to find out if some specific tag or some specific context exists in that particular specific XML document. Language control, just like classes or events, so it will be more like we are writing a program, not writing a query or that we normally do in the SQL, that is structured query language. So to start with a very simple language, simple example, you can say that. So it's an integer, we are writing a scores, which is an integer type array, and then we are saying that enumerable score query. That particular specific query is going to return me a list of integers because it will try to find out specific numbers in that particular specific array and return back something which is enumerable int, is kind of an integer list. So what we are saying that from score in scores, this is of something which we can say that it's a variable, and that variable will query into the scores. So what will happen that this particular specific query is going to, this score is going to be equal to 97 first it will become 97, and then where score is greater than 80, so we are applying certain conditions. If that score is greater than equal to 80, we are going to keep that particular specific score and return in the list that is going to be returned from that particular specific LINQ query. Okay, so then that particular score will become 92, 81. So if we look at that particular specific thing, so 97, 92, 81, they are all greater than equal to 80, so they fulfill that particular specific condition, so they will be returned back in that particular specific query, and 60 is filtered out, it is not going to come into that one. Okay, and then at the end we are just trying to execute that particular specific query, and we are printing the results on the screen, and it will return 97, 92, 81 excluding the 80, 60 because it is not a score. When we put 60 as in place of the score, then it does not fulfill that particular specific condition that score is greater than 80. So what happened? So this is our integer array or a sequence or a list. Then we apply the score is equal to 97. 97 is greater than 80. Yes, it will be remained in this query. It will be selected. Again, 92 is selected, 81 is selected. But on the other hand, when we talk about 60, it is excluded, it is not selected, and it will not be. This is the thing that is going to be returned when you say select. When you say select score, it will return me a list of these three numbers excluding the 60. So query operator accepts a sequence and give an output sequence. Also give also an output sequence, a list, array, you can say that in simple terms. So using system.link, this is the library from where we can, if we want to use that particular specific links query structure, then we have to include that particular specific using system.link statement in our program, in our class file. Otherwise we cannot use that particular specific link structure. We also can represent those link syntax in the lambda syntax or the query syntax. Lambda syntax is more simplified, writing the things in a compact form in a minimum possible way. On the other hand, query is much more elaborated. So I will give you the example, the difference between them. So we have this particular specific lambda syntax. So this is a string of it's a words, it's an array of words, and then we have, say that this is a lambda syntax that's long words. Again, it's a query that we are writing. It will return me back again a collection or list. So words dot where, rather than we say that from word in words. So we are saying, say, words dot where w lambda arrow dot w dot length is greater than 10. So what does it mean? That it will place hello, wonderful, link, beautiful and word in place of the word and check their length. If the length is greater than 10, it will remain in that particular specific, it will be returned to the long words. Otherwise, the words which are less than the length of those words is less than 10, they will be filtered out. So this is our lambda expression. On the other hand, if we look at that particular specific query syntax, in this more like a variable short words, and then we say that from word in word. So now we have from, in, where, select. So we have different type of clauses that we need to write, just like we are writing a SQL query. If you are familiar with, I'm pretty sure that you are familiar with the database development. So in this you have a structured query language, that is SQL, and you need to write. So it is also more like a very well structured or query syntax that is presented in this particular specific LINQ framework. So from word in the words, again that word is going to be replaced with hello, wonderful, link, beautiful, world. So and then check if the length is less than or equal to 5, then it will be returned in the short words, otherwise it will be not. So we have different types of the link: a link to the object, link to the XML, link to the data set, link to the SQL, and link to the entities. When we talk about the database development, we will be talking about link to entities and link to data sets. So that is going to be we will discuss when we are discussing the database development in the C#. But today we are going to talk about the link to the object and link to the XML. So again, if we look at the LINQ architecture, we have VB, C#. These are the different languages which are present in the Visual Studio or in the Microsoft programming suite. So we have .NET language integrated query, that is language integrated query, that's called LINQ. And then we have link to objects, link to data set, link to SQL, link to entities. It is more like, if you look at that, they have grouped all these three together because they are related to the database development. So and then we also have the link to the XML, and that these three will be covered in the future lecture. But today we are going to cover these two: link to the object and link to the XML. So first of all, LINQ query expression, it is more like a structured query language type of expression. We have a select, we have where, we have order by, started from the keyword form. We always start whenever we are writing the query syntax, in the query syntax, that LINQ query, then it always starts from the keyword form, and there are 40 different operators which are present in that particular specific link. And if you go to that particular specific link, you will find out the more details about it. Some of them we will cover here, but of course we can't cover everything here. So simplest query, one input sequence and one operator. So we can simply say that we have this is in the Lambda expression. So it is a composite operators chaining of the query together. So here we have a string of names, and then we have query that is going to return me a string type list or string type enumerable collection. We are saying names, and because we are using the lambda expression, so we have dot where names dot contains a. So we are saying that look in that particular specific names array of strings and find out all the names which contain a. So if you look at Tom, it will be excluded, Kim excluded, Harry included, Mary included, and J will also be included. So if you look at only this thing, names where that particular specific condition fulfills, then Harry, Mary, and J, these are going to be returned. Now once they have been returned, we are saying order by name dot length. And now if you look at that, the length of the J is 3, length of Mary is 4, length of Harry is 5. Okay, so now we are saying order by. When you say order by, it will automatically order based on the criteria that we have given. Here the criteria is the length of that particular name. So when we talk about length, it will automatically order them into the ascending order. So it will, J will become the first in that collection or the list, Mary will become the second member of that list, and Harry will become the third list. And then we say that dot select, it always finish at that select means that we are selecting that. And then what we are going to do that if we only say select name, and it means that we are not going to do anything, and then it will be stored in the queue, J, Mary, and Harry as it is written, it is shown on the screen here. But now we are saying that no, don't make them to the upper, so it will convert that J, small a, y, J is already capital, A, Y is small, so it will convert that into the capital J, A, Y, capital letters, Harry capital letters, Mary capital letters. It will convert all the letters into the capital letters and save them. And then once we have what you can say that when we print them on the screen, so that will give me the J, Mary, and Harry. And first of all, we will apply this particular specific thing where class, that we will select these 3 names because they contain the A. Then we order them based on the name length of their string, so they J, Mary, and Harry, and then we are converting to the uppercase letters. So this is how things are working. So we have the input sequence, filter, we will apply filter using the where class, then we apply sorting based on the orderable class, and then we have the project, we apply certain specific processing on all the filtered and sorted data, and we convert them to the upper, and at the end we are getting the output of that particular specific sequence. So we can also do them in a separate way, like filtered end dot contains A, so we say finish. And now we are not saying that we apply a specific one clause which is filtering, that is where clause, on the names. And now from the sorted is equal to filter, now we are applying another order by class on the filter, so filter dot order by end dot length. And then we can write them in a separate, or we can write them into the one form that is we have written before. If we are writing in this particular composite form, then we are doing everything as it is, so there is no way that we can modify that particular specific behavior. But if we are writing all those things like filtered, sorted, and final query as a separate thing, then we may, it's not necessary, but it is, we may want to sorted them based on certain specific condition. Then we have a if statement, and if that condition is true, then we are going to sort it, otherwise we are not going to sort it. So we can apply certain different type of sorting algorithms based on different conditions. So then in this case we have to separate them out into different components or different statements. So again we have a lambda expression, so we can also reverse. This is again we apply the where, then order by, then we say reverse. And now what will happen, the Harry will become first, Mary will become second, and J will become the third. So I mean we are reversing the order of that particular specific sequence. Okay, so we can apply those chaining operators as many as possible that we want to do. Okay, so there are 40 different operators, so we can apply all those 40 in whichever order and how many times, doesn't matter. Lambda expression in a query operator always works on individual elements in the input sequence. So as we have seen that, so we say names. So actually it will look at Tom, then it will Kim, Harry, Mary, and Jay. It will look at individual elements, and that's what. So not the sequence as a whole. So it will look at individual elements in the sequence and apply the filters or ordering or selection. It will apply those things. And then we also have a query syntax chaining. In the query syntax we say from n in names, where n dot contains this, and then we have order by, and then we select. And remember that whenever we are writing in the query syntax, it always starts with from and it always ends at the select. So again, in the query syntax we have from, then we put the identifier or the name, type name, and then we say that in the enumerable, that is an expression or the collection. When we have order by, where, identifier, we apply all different type of, this is more like a structure of that particular specific thing. And if we are having join, inner join or outer join, so we can apply all those kind of joins that we know about in our database development. We have inner join, we have outer join, different type of joins when we are joining different tables together to find out certain data. So here we can also have multiple collections from which we are trying to query the data, so we can combine them together. We can apply certain inner expression and outer expressions, or the inner identifiers and so on. So link chaining operators always starts with from and either with the select or a group by clause. Either we are selecting it, and then we are group by, it means we are grouping the output into based on certain specific criteria. Again, we have take, skip, reverse, first, last, element at, count, minimum, contains. So all these operators which are present in that query that we can apply into the in our LINQ query. In the LINQ query, syntax cannot use a variable before. You can declare it. Subquery is another C# expression. We can have a query within the query, so that is called subquery. So that is also a separate expression in the C#. Data flows from left to right. It will always starting from the outermost and go to the right side. Pipeline of the operators. We have operators, and we have that we apply in a pipe, in a chaining chain. Reference a table alias is select class before defining it in a from class. So we can reference a table. Subquery subject to the special rules. Here we have a separate expression, but here we have whenever we are having the subqueries within the query, they have subject to a special rules. Less well structured than with regard to the data flow. Comprises a network of the classes that work mostly with unordered sets. So the way that we are applying different clauses in the SQL, they are not very well ordered, so mostly they are applied in a different way. So to understanding how they are applying, so that's become a bit tricky when you talk about the SQL language. So execute not when constructed but when enumerated. Deferred execution. What does it mean? It means, if we go back to some example here, when we are writing this query, it is not going to be executed. We have defined what you can say that we have defined the context, we have defined the where filtering, we have defined the order, we are defined to the upper. But this particular specific, what you can say that query is not executed when we have defined in this particular specific statement, unless and until we want to use this query and print them on the screen. So that is, we defined it, we what you can say that we created that query, we have explained that query, we have constructed that query, we apply different operators, but it is not going to be executed unless and until it is being used. So decouples query construction from the query execution. So query construction is a separate thing and query execution is a separate thing. And every time whenever you are going to use that query, that object or the variable that we have declared in the enumerable form, that is going to be re-evaluated every time that we are going to use it. For example, if we are saying that we have an integer list 1 and 2, and then we are defining a query that is selection n and n multiplied by 10, so it will become 10 and 20 actually, but at this time the query is not executed again for each int n in the query. Now we are trying to use that query in our for each loop. So here we are saying n in the query, so now we need to enumerate, we need to get and find out the values. So we say write to console n into, so it will print 10 and 20, and then numbers dot clear. Now when we set numbers, this is the space because the query is executed, query has been defined on the numbers, and at that particular specific time when we are using in the for each loop, the first one, this particular numbers contain 1 and 2, that list contain number 1 and 2. So when we try to print the numbers using the query number 2, it will print 10 and 20. Now we are saying numbers dot clear. It means that we have emptied that particular specific number list or integer list. Now it contains nothing. So when we are going to use in again that query number 2, and it will try to re-evaluate, it will re-execute that particular specific query, and right now it is nothing in that particular specific list, so it will also return me a empty list. And now if we try to print something on the screen, it will print nothing on the screen. So that will tell you that the query, when we are defining the query, it is not executed. When we are using that particular specific LINQ query, then it is executed on the time of its usage, and every time you use, it will re-execute that particular query and update the data. Sometimes it is not necessary and sometimes it is necessary. So we need to be very careful that if we are defining the queries, it will be executed every time whenever we are going to use. It will be re-evaluate that particular specific expression. If the original data has changed, then query is not going to work as we expected. So we need to make sure that what exactly we want. We want to get the update in the data, or if the data is updated, do we want to keep that query in that form or not? So that's very important. So not good, record data at a specific time. If we want to record data at a specific time, if the query is computationally intensive, querying a remote database, for example, we have a LINQ query to a database, and that is a remote database. We need to fetch a lot of records. I don't recommend to write a LINQ query. Why? The reason is that every time you run that query, that particular program is going to open a connection with the remote database, bring those records. If there are thousands of records, it will bring those records back there, apply those processing again and again, and if that data is not changed, then we are doing that particular specific that particular specific exercise for nothing, because we have already processed that particular specific query. So for that, what we can do, we can try to convert that result into a 2 array or 2 list, so that we can copy the output of the query, and then now we are not going to use the query again, rather we are going to use that particular array list, and then we can later on update into the database if there are some changes in weight. Okay, so that's very important to understand the deferred execution, and every time you use that query or that particular specific LINQ statement, it is going to be re-evaluated. And if we are having intensive system that is what take too much time and data is not changed, then we don't want to re-execute that particular specific query again and again, because that will decrease the efficiency of the program. And this is again how deferred execution works. So it will just create that particular specific structure. It is not executed unless and until you have been defined. So again, we have a change. So we have we start from the request of the data coming from the select query, and then select go to the sorted, go to the ordered, go to the source, and then so on. So start the request for the data will go from outermost to the innermost, but the data flow is on the other side, is from the innermost to the outermost. So first it will apply the filter, then will apply the ordering, and then it will select and perform some certain specific things on each individual object, and then it will return the list. But the request start from select, then it go to the order by, then it go to the where, and then it go reach the original data, and then the data is served in the reverse way. The same thing, what you can say that the same thing that has been defined in another way. The request is going from right to left, and the data is coming from the left to right. A query constraint contained within the another query, so that is also possible. We call it a sub query. So we say that from n in names, where n dot length is equal to. Now instead of providing the value here, we are writing another query, and then we say from n2 in names. Again we are talking about names. n2, a different variable, ordered by n2 dot length. We are ordering them based on the length, and then we are say that select n2 dot length. So when we select, it will not select the name, that is, I mean, if you say that we have a Tom, Kim, J, and so it will select only the length. It will provide an integer value as a return, and we are getting only, so it will contain what you can say that if we don't apply the filter by or the first, then it will return me 3, 3, 3, 4 and 5. So that will be the output. But now we are saying that dot first, take only the first element. So we have 3, 3, 3, 4 and 5. So 3 is the first element, so it will take the first element and place that particular specific value in that one. So now after the execution of this sub query, it will become where n dot length is equal to 3, select n. So all the names which has the minimum length, that is 3, they will be selected. So of course, if we look at in a simplest form, that Tom, Kim and J will be selected, and Harry and Mary will not be selected. So that is we have query within a query, and this is the outcome of this particular specific complete query. Same thing that we can use for the lambda expression. Here we say n where names dot where n dot length is equal to names dot. Now again we are saying names, and then we are applying dot order by n2 dot length, select dot select n2 where n dot length n dot first. So we are applying that particular specific thing, and again it will give me back. So here what will happen here, so first it will apply the sub query on the data. It will apply that sub query, find out the value 3 and replace it in the outer query, and then it will execute the outer query and give me back the J and Tom, or the Tom, Kim and J. Okay, I mean here we have different names in input values, so that's why we are getting a different. But if we talk about here, this input value, that was going to come out from that particular specific query. So we have composition strategy, we have progressive query construction using the into keyword, or we can wrap the queries. So we can combine different queries together, progressively developing the things, just like we have developed like filtered is equal to this, and then we have sorted, then we have query progressive. So we can say select dot sorted dot selected. So we apply different type of step-by-step process. So each of the participating query operators returns a sequence. Filtered is also a sequence which has been named .where, and it contains a. Then we have sorted ordered by the length, and then we have the query progressive, the sorted dot length. So this is again we are component dividing them into the component, and each query is serving to the next level. So easier to write, apply query operators conditionally. Again, as I told you, that if we want to apply different orders based on different conditions, then we can have if else conditions, and based on that particular condition which have been fulfilled, if we will apply a different type of ordering here. So that is also possible only in the progressive one. Apply the query operators conditionally. So if there is something, then we can apply, otherwise we can't. So that is what we are going to happen. So continue a query after a projection, and that is called into. So what we can say that if we from n in names, now we are starting with here, and then we say that we are select and dot replace. So what we are doing, we are replacing a, e, I, o, u with nothing. It means that we are removing the vowels, and then we say into no vowels. Now what do you mean by this? It means that the result of that particular specific query, that is going into this particular specific query as in input. The sequence that has been returned by this one, it is going to as an input into the no vowel. And then we say that where no vowel dot length is greater than 2, order by no vowel. We are ordering based on the a, e, I, o, u, alphabetical order, and then we select no vowel. And then when we try to write the numbers, it will give me Harry, Mary, without any Harry and Mary, without any vowel inside it, because we are saying that the length of those words or no vowel words should be greater than 2. So these are 3 and 4. So this is going to be returned based on that particular specific query. So here into execute this first query, and whatever the sequence is coming out, that is go into the second query. Okay, so that is again we are developing the query in a progressive way, or we can say that in a chaining thing. But here we don't have the possibility that we can apply some conditionality on the application of different queries. Into either used after a select or a group class. Again, once the previous query has been finished, and we know that once we have write a query, it always ends in the select statement or the group clause statement. So into always comes after the completion of the previous one. Into restarts a query. Whenever we say into, it will restart the query, and we can introduce where order by classes again in that particular new query as well. So we apply all the rules which we can apply to build a LINQ query. So starts again. Yeah. So variable scoping, when you say for n1 in names, select n1 dot to upper and then into n2. So once this particular first query has finished, we can't use this n1 again in the inner query, because that is something which say that I can't recognize, it is not in the scope, I can't understand what you mean by n1. Yes, we can use n2 but not n1. So that's need to be careful that the variable that we are using in the first query, we can't use them into the second query after the into keyword. Here we are talking about the syntax, query syntax, and this was the lambda syntax. Wrapping the queries, again we can wrap the queries. Build progressively can be formulated into a single statement by wrapping one query around another. So this is what you can say, that we have this particular specific query, and then we say query from n in the query. So now we are using that particular specific query inside the other one, that is called a wrapping. Okay, the similarly thing, what you can say that this is in the syntax form, and here we are trying to use that particular specific thing. So here we are building what you can say that the progressively, here we are saying that wrapping the things. So we are from n to in the names, we are replacing. So instead of first replacing that thing and then we are trying to use that particular specific length and order by, so we are saying that from n1 in this query. So first it will execute, it is more like a sub query, or it is more, so it has been wrapped within the query. So again this is more like a sub query, and we can also apply the link to the XML document object model, well designed and efficient, set of 10 different query operators we have here, and we can apply. So here is, and this is a sample. So I have a string my XML, so I just write down a sample XML in which we have first name, we have last name, and then we have the customer. So we can apply on the X elements, we have names equal to customer attributes, and this is the what you can say that the document structure of that particular specific. So now what we can do, so we have my XML, add the departments, we have that particular specific string, which contains a specific XML tags. So we say X document is equal to new X document. We created a new XML document. X document dot parse my XML. So it will parse that particular specific string and create a structure like this. We have the customer, then we have attributes, we have first name, and so it will create that particular specific structure. And then we can pass that particular specific, we can apply the LINQ query to that particular specific XML document, X document dot element department. So it will look the department elements at dot elements departments dot descendants, all the values which are present in that particular specific departments. We want to get those values in the elements. So and then for each X element I in the element, I want to department name, so it will print that particular specific names of the departments I dot value. So it will create, it will it will query that particular specific document and find out the departments, and then we can, from these departments we can find their names. So that is the simplest form that I have shown you. We also have that particular specific XML document which is available online. We can also connect with the online document and parse it. So it is the sample of that, but it has some information about the plant. We have blood root, mostly shady, what is the price, what is the availability, and so on. So this is an online document which is present in the web. So I can just simply say X document from web X document dot load, and then we gave that particular specific URL. If we load that particular specific document into the X document, and then now from that document we can find that from web dot element catalog. So if we look at that, we have the element catalog. In the catalog element, we want to find out the plant. So we have the plant, and then we are saying that dot descendant. So what will happen, it will take all the values that is present here, common, botanical, zone, light, price. So it will take all those values, and once it will take all those values, we are saying that X element I in the element, write plant details I dot value. So it will print those values. Okay, so it will plant details, so it will say that for each element, blood root, so it will print all the details of each and every element. Okay, so and that is the end of our lecture for this LINQ, and in the next video we will be discussing about the database development. Thank you.